In this video, we're going to tackle solving a radical equation. So an example here is very simply the square root of x is equal to 3. And we can kind of do this particular question in our head and most of the easy ones in our head. But if we wanted a framework for how to do this, what we would do is use the fact that square roots and squares undo each other. I use this in like quotation marks. So since they are inverses of one another, they undo each other, we can actually do this to both sides of an equation. We can square both sides of the equation. It's okay, we're being fair. So if we take x, the square root of x, and square it, we'll pretend to be slow about this. Well, that's square root of x times the square root of x, which is the square root of x squared, which we know is just x, right? So this probably wasn't necessary to do all of this. We could have just said, okay, I know the square root and the square undo each other, so this is just x. I could also remember off to the side, our x, square root of x is equal to x to the 1/2 power, and we could think about squaring that, which would leave me with just x to the 1st power, or x. So that's another way to think about this. And then the other side is 9. And then we can check our work by just plugging on in. The square root of 9 is equal to 3. Perfect. Now, there are two ways that we can kind of get in trouble or make mistakes with this particular thing, right? This squaring both sides idea, raising this so both sides to this particular power. And one is, imagine we had another simple example. The square root of x is equal to -2. If we're clever and we think about this before we just start doing crap, which is always my recommendation, we remember that this square root is a principal square root. It has to be positive, so this is impossible. But if we're not paying attention and we're just following a set of rules, we go, okay, sweet, I square both sides, and then x is equal to 4. I'm awesome. But if we check this, the square root of 4 does not equal -2. This is absolutely not okay. So I just want to throw out there that there is this potential issue with squaring both sides where we can end up with extraneous solutions. So you really have to check, must check solutions, because sometimes it's not this obvious, right? This is a particularly obvious one, but let me show you an example where we don't have that. New example really highlights the two potential issues that can happen with solving a radical equation. If you want, I say pause the video, try this out, see if you run into or make either of these mistakes on your own. So one mistake, potential mistake, is to do this. Square both sides. You see the square root and you get excited and you square both sides. But what will happen if you do that? Mathematically, you're squaring something that has two terms. So you actually have to think about how that distributes, right? You would have to sit there and go, okay, this has got to distribute to both those, that's both those. And all you've succeeded in doing is making a really hideous thing where you still have x trapped under a square root symbol and you haven't done yourself any good. So you absolutely do not want to square both sides this early. If you were thinking of a rule to this, what you want to do is you want to isolate your square root before you square both sides. Because if this is not isolated, you're just going to end up with it right back when you do your distribution. So the first thing you should do is subtract 6 from both sides of the equation. Now we have the square root of x is equal to x minus 6. Now when we go to square both sides, we have accomplished our goal on the left side, right? The square root of x squared is just x. Hurrah, x is free. We no longer have to deal with the square root that it was trapped under. But the other side, we do need to be careful and make sure that we think about that distribution. This is x minus 6 times x minus 6, which you can check for yourself. I'm not going to do it. It's x squared minus 12x plus 36. Now, herein lies another issue. We just ended up from this radical equation to what we have as a quadratic equation. We know this because of the x squared. So now we have to remember stuff that we had back on an old exam back in the first half of the class, that in order to solve a quadratic equation, one of the ways we would want to do this pretty much any of the ways we'd want to do this involves setting aside equal to 0. So we got to do that. So now we have 0 is equal to x squared minus 13x plus 36. Now in basic algebra classes like Math 92, as soon as you have something that started out as a difficult, different type of a question, and it turns into a quadratic after you've already done a lot of work, this quadratic you can solve by factoring. Obviously, you could use the quadratic equation, but there's no need to for this type of question. It should factor. So in this case, we just need to come up with what multiplies to 36 and adds to a negative 13. And sure enough, this should be x plus 9, or x minus 9 times x minus 4. And then we use our zero factor property to figure out that x is either equal to 9 or x is equal to 4. Now here's when that extraneous solution thing comes back in and is incredibly important, because we don't know if these both work. When we square both sides in this step, we potentially created extra answers. So we need to double check, right? We could have been in this situation where we squared a negative and got out that it equals a positive. So we need to plug these back in. So let's try the 9 first. So x is equal to 9. The square root of 9 plus 6 is equal to 9. 3 plus 6 is equal to 9. Perfect. That makes sense. X is equal to 4. Well, the square root of 4 plus 6 is equal to 4. 2 plus 6 is equal. That doesn't work. So this is not a solution, but this is. And again, you can actually see where the problem was. If this had been a negative 2, this would have worked out perfectly. But since our principal square root is always positive, this doesn't work out, and that's why we have our extraneous solution or our problem. All right? So, that being said, I think we've done enough of the solving. If you want one more example, I might have time to make a video later, but for now, I think a 7-minute video is fine.